Hello, we're on lesson 15 on unit 7. So it says my science teacher told her that when there is more ice touching the water in a glass, the ice melts faster. She wants to test the statement, so she designs her science fair project to determine if crushed ice or ice cubes will melt faster in a drink. She begins with 2 cups of warm water in 1 cup. She puts a cube of ice. In a second cup, she puts crushed ice with the same volume as the cube. What is your hypothesis? Will the cube or crushed ice melt faster, or will they melt at the same rate? Explain your reasoning. Well, my hypothesis, and this is just mine, yours could be different. My hypothesis is the crushed ice will melt faster because it is smaller. I'm thinking of you have a cup, okay, and you have these big ice cubes that need to melt. There's more volume of them that needs to melt than if it was like the crushed ice with like little cubes, little crushed ice ones. So I feel like the water would make these melt faster. Okay, let's go ahead and go to 15.2. Revisiting a box of chocolates. Forrest Gump. Okay, the other day you calculated the volume of this heart-shaped box of chocolates. The depth of the box is 2 inches. How much cardboard is needed to create the box? Okay, so we have to, so they're pretending that like we actually have the box. It's a real live box. It's 2-dimensional or 3-dimensional. So we have to cut it somewhere. I think we're going to cut it here. Because like I told you guys, we need to make a net. So I told you guys that on the last lesson. I like making the nets. Okay, now this side here, all right, sorry, I wanted to show you guys a picture. So here is that box. Remember how I said like it's 3-dimensional? This is what the box looks like, 3-dimensional. See how there's that? This is the part that we have unfolded and we're laying it out here. Now, here's the deal. This part here, you guys would not be able to figure out. I'm going to write down what these pieces are, and you guys will use my numbers. Okay, so we're going to use those. We're cutting there, okay? So we have 2.2, 2.2, 2.2, that's 2.2. Then we have 2, 6.7, 6.7, and 2. All right, and then remember this is 2 because it says it's 2 inches. Okay, so now we can add all these together, which when I added them together, I got, so 2.2 times 4 plus 4 plus 6.7 plus 6.7. I think I got 26.2. So from here all the way 26.2. Okay? All right, so 26.2 times 2 makes the area of this 50 2.4. Now, we still have to find the area of the inside here. And I think we had found that the other day. So if you want to go back and find it, you could. So there we go. Okay, so first off, we have this rectangle, 2 times 4, 5, 6, 7, 8. That's 8 across, and that's 2. So this rectangle is going to be 16. This is 8 across times 5 times 1/2, because this is 5. So 8 times 5 is 40, times 1/2 makes this 20. This here is 4 and 1. So 4 times 1 is 4, times 1/2 makes this 2. And this is also 2. So if I add those together, the area of this base is 36, 37, 38, 39, 40. So base equals 40. Now, remember, there are two bases. There's a top and a bottom. So 40. Now we can add these together. So 4 and 2, 8. One. Jiminy Christmas, guys. All right, and then it's going to be inches squared because it is surface area. All right, awesome. Card sort. This is going to be a Desmos activity on Classroom. Go ahead and do that at the end, okay? Do that at the very end. All right, next. A wheelbarrow of concrete. All right, so it says, a wheelbarrow is being used to carry wet concrete. Here are its dimensions. So this must be like the wheelbarrow, like if it looks three-dimensional. This must be the side, like the base. I know we're calling it a base. A base on a prism is anything that there's like two of, you know? So this is the base of it. All right, so what do we got to do? What is the volume of concrete it would take to fill the tray? Well, here's the deal. Remember, volume, you always do area of the base times height of the prism. Okay, so we have to find the area of the base. Here is the base right here. Remember, we talked about this is the base. Even though that's not what it sits on, it is the base. Okay, so we have to find the area of this and multiply by the height of the entire thing. So that's if we stood it up on its base. So they say this. So I think what we should do is find the area of this. This is a triangle, so that part is 1/2 34 times, and the height is 66. So now in your calculator, 34 times 66, and divide that in half, and that's 1,122. Now, this here is a trapezoid. Remember, trapezoids are 1/2 base 1 plus base 2 times the height. Base 1 is 40. Base 2 is 106. 1/2 40 plus 106 times the height, which is 66. The height's right here. Okay? All right. So 40 plus 106, 146. So we can just take half of that. 73 times 66, 4,818, plus that, so 4,818 plus 1,122, we find that the area of that is 5,940. So, and now we have to multiply it by the height of the prism, which is 70. So, over here, 5,940 times 70. And we get 415,800. And what's our label for this? Centimeters cubed. You always label volume with cubed. Okay, after dumping the wet concrete, you notice the thin film is left inside the top of the tray. What is the area of the concrete coating of the tray? Remember, there's no top. Okay, so basically, they want us to figure out what the surface area is minus the top part. So the good news is we have the base twice because we did 4818 plus 1,122, and that was 5,940. So that's both of the bases, 5,940 times 2. So that's the first one, 5,940 times 2, and that's for the base. Now, we're going to have to get the part that goes around here. So it's like if we were to cut here. I'm going to draw it here. All right, if I cut it there, this piece is 74, and this is 70. This piece here is 40, and then this piece here is 93. That's why they had those here, 74, 93, 40. Okay? Remember, we don't have that top part, so we don't need it. So, we can add these up. 93 plus 40 plus 74 is 207 times 70, and that is 14,490. So we're going to add that to it. And that is the sides. Okay, so let's do the math. 5,940 times 2, that is 11,880, and we got to add that to the 14,490. $26,370 centimeters squared because that's for area. And that looks good. All right, so go ahead and read the lesson summary. Please do the practice problems for homework and make sure you get your exit tickets done. This is, so when it goes for the test, there's one more lesson. So we got to do lesson 16, which we will do on Thursday, and then we will be having a test next week. So please make sure that you are keeping up with your work. Have a wonderful day, and I will talk to you later. Goodbye.